Hey guys, Travis Gillespie. In this next example, you'll be given some coordinates. Plus, you're going to be told that it's a square. But you're going to have to find the coordinates of a missing vertex here. So let's graph this and see if we can find out the missing coordinates of, well, the coordinates of that missing vertex. Now remember, a square has two pairs of parallel lines, so I'm just going to draw some, or two pairs of parallel sides. I'm just going to draw some lines here. Let's thicken this up some, just so it pops up nice and visible. Well, that's not what I wanted to do. Get my line tool out. Cool. And actually, when it really comes down to it, I can guess what my last point is going to be, but I don't want to do that. I don't want to just guess. Well, I need equal distances, so it looks like 1, 2, 3. Well, let's see here. 1, 2, 3, and 4, and negative 1, 2, 3, 4, or 1, 2, 3, and 4. Yeah, it looks like if I want equal distances, 1, 2, 3, and 4. I'm thinking I'm gonna be somewhere around this area right here, and I'm gonna actually change that color. Cool. So I'm somewhere in this area right here. That's where I'm feeling that I need to be. And remember, the big goal is I want equal distances. Maybe even get a spray paint on that, just to actually really mark the spot that I'm wanting to be at. I'm really wanting equal distances with my other parallel lines. Well, if the coordinate is here, how can you check to see that it is supposed to be there? Well, one thing is you need two pairs of parallel sides. And in order for them to be parallel, the slopes have to be equal. Well, a square also has four right angles, so in order to be perpendicular, the product of the slope has to be equal to -1. Well, let's check the slope of segment CB and segment DA. I'm going to call this last slope down at the bottom D, or not slope, but actually, I change that up there. I'm going to call this last point segment D. But the slope of segment CB is up. It rise 1, 2, 3, 4, and over 1, 2, 3, 4. So the actual rise over the run, the slope for CB is 1. Well, if you check the slope of segment DA, you actually get the similar value, actually the same value. Excuse me there. And what you find is, hey, I rise 1, 2, 3, and 4, and run over 1, 2, 3, 4. My slope is actually going to be 1. So you have 1 and 1. Let's check the line segments of AB and actually DC here. So let's see. Hey, well, if I rise 1, 2, 3, and let's see, 1, 2, 3, 4, and back 4. Well, I have a slope of -1 here. And hey, 1, 2, 3, 4, and over 1, 2, 3, 4. I also have a slope of -1 over here. Well, notice this side and this side are parallel because their slopes are equal, -1. And also this side, they have the same slopes of +1, so they are equal. And by saying they're equal, I mean they're parallel because their slopes are equal. Well, the next question here is, are any of the sides perpendicular? Well, remember, to be perpendicular, the slopes have to be, the products have to be equal to -1. So BC and BA, their product of their slopes have to be equal to -1. So the product of -1 times 1, or 1 times -1, equals -1. Therefore, yes, slope BC is perpendicular to BA. Let's keep looking. Well, -1 times -1 is also equal to -1. So these two are perpendicular. 1 times -1, the slopes are equal. The product of them are equal to -1. And again, the products of these slopes are equal to -1. Therefore, the missing vertex, or the missing point, D, the points are -1, comma, -3. X is equal to -1, Y equal to -3. Cool stuff.